trigonometry and one from the real number. Okay, and let us solve those questions one by one. So the first question was that there there is a triangle. Okay, there is a triangle whose interior angles are A, B, and C. Let's say any triangle, right? And whose interior angles, let's say this angle is A, this angle is B, and this angle is C, right? It's given that. Now we need to prove what we need to prove. We need to prove that sine of B plus C divided by 2 is equal to cos A by 2, right? And the another one is cos of B plus C by 2 is equal to sine A by 2. This we need to prove. This we need to prove, right? So this is the question, right? So how to solve such questions? You can see, since the main data is given into this question is that A, B, and C are the angles, interior angles of triangle, any triangle A, B, and C, right? These are the interior angles. So if these three angles are A, B, and C, right, we know the property of triangle, that the sum of all angles of any triangle, okay, is equal to 180 degree, right? So can't we write A, angle A plus angle B plus angle C is equal to 180 degree? Can we write it or not? Tell me. If we can write it like this, then in the second line, do one thing. Since we need to prove B plus C by 2, right? It's B plus C by 2. So what we can do, we can simply put it as it is. Let me show you. Let me show you. Actually, this page is coming outside, so that's why, yeah, it's fine now. So a plus b plus c equal to 180 degree. That means in the statement which we need to prove, sine of b plus c by 2 is equal to something, and cos of b plus c by 2 equal to something. So here just take this b plus c, this b plus c, and push this a to the RHS. Then we can write it as b plus c is equal to 180 degree minus a, isn't it? Minus a, because this a will be coming from LHS, going to from LHS to RHS, right? Now do one thing, divide both the sides of the equation by 2, this one, right? When you divide it, what will be the next statement will be, the next line will be b plus c by 2 is equal to 180 by 2 minus a by 2, isn't it? And when you write the next line, we can write b plus c by 2 is equal to 180 by 2 is 90. It's 90 minus a by 2, right? Now what we will do? Simply, here in the first proof, we need to take sine of b plus c by 2. So when you take sine of b plus c by 2, our LHS will be the same. So do one thing, in this relation which we have derived, right, take sine in both these sides. Okay, when you take sine, it will be sine of b plus c by 2 is equal to, since sine is taken in both these sides, so sine of the RHS will be sine of 90 minus a by 2, right? But sine of 90 minus a by 2, that means if this angle a by 2 is theta, if this is theta, this is into the form of 90 minus theta, right? And sine of 90 minus theta is what? It's cos theta, isn't it? So sine of 90 minus a by 2 will be equal to cos a by 2, this one. And in this way this is proved, right? So we can write, just to recall, sine of 90 minus theta it's equal to cos theta. We have put it. Okay, this is just to recall, right? Then we can simply write sine of b plus c by 2 is equal to cos a by 2, because sine of 90 minus theta is cos theta. So in this way we have proved the first part of the question, right? Similarly, take the second part. In this is proved, this is proved. Now in the second part, cos of b plus c by 2 equal to sine a by 2. Now, whatever we have derived, b plus c by 2 equal to 90 minus a by 2. Now this time take cos of this, right? So when you take cos of it, it can be written as, since b plus c by 2 equal to 90 minus a by 2, right? When you take cos in both these sides, cos of this, right, and take cos into the RHS also, then the LHS will be cos of b plus c by 2, right, b plus c whole into the bracket divided by 2 equal to cos 90 minus theta, and cos 90 minus theta will be sin theta, right? This is with the same relation. What? The formula which we used over is here, that cos of 90 minus theta is equal to sin theta, right? So using the same, we can write the above, that is cos of b plus c by 2 equal to sin a by 2. Now in this way we have proved the second one, cos of b plus c by 2 equal to sin a by 2, and this is solved. Now coming to the second question of today's live session, right? What was that? 67, tell me. 67 power 67, yes. So let me write the question, okay? 67 power 67, so that will be, just I am writing it over here, yes, yeah. The question was that 67 power 67, right, plus 67, when all this is divided by, 68, right? What? 68. Then what will be the remainder? What will be the remainder? This was the question, right? Now this is a question from real numbers. So what we will do, just do one thing, divide both these numbers individually, then we can write 67 power 67 divided by 68, isn't it? Because this 68 is dividing both of these terms. This is the first term, this is the first term, and this is the second term, right? So divide it individually, then you can get 67 power 67 divided by 68, plus 67 divided by 68. Now we are going to find the remainder. So here we are going to take the individual number 67 by 68, right? You know, when you are dividing 67 by 68, right, then simply you can understand from 68, when you are dividing 67, right, it would not be completely divisible. Why? Because it is not 68, it is less than 68. So suppose we had added plus 1 over here, right? Then in 1 times this 68 would be divided, right, and we are left with 0, right? But here this one is added over here, so that's why that one was earlier not present. This is inserted, this is inserted. So that's why, since this one was not present over earlier, so this one need to be subtracted from the remainder, right? So the effective remainder is not 0, it's minus 1, right? Because 0 minus 1 is equal to minus 1, right? Now this minus 1 will be the remainder for 67 by 68. So the first number 67 by 68 will give you the remainder minus 1, right? 67 by 68, 67 power 67 by 68 is there. So when one of these is divided, then minus 1 will be there, right? As I have shown you, and power of this 67 times. So since this is an odd multiple, right, so we can write minus 1 effectively for this entire, right? So minus 1 is the remainder for the first term, that is 67 by 67 power 68. This will gives you minus 1 as the remainder, right? And for the second term, this one, the remainder is already calculated as minus 1, right? So for both the terms, minus 2 will be minus 1 and minus 1 will be there, right? Minus and minus 1, this will give you minus 2, right? So when this minus 2, let's say minus 2 is divided by 68, minus 2 is divided by 68, right? This will be not the same as we have derived, because 68, it would be completely divisible when, as we have proved earlier, you can see here, for making it completely divisible, 66 should be added into it, right? Or we can say simply, for simple 2, 66 should be added, right? So we can say simply that this minus 2 is the effective remainder over here, right? And it's divisible by 68, so complete answer will be 66. Why? Because from 68 it would have been completely divisible when 66 will be added. So that is effectively your 66 is your remainder, right? This is your effective remainder, right? I hope you understand. If not, let me know. I will explain it again. Okay. So what I said, since 67 power 67 divided by 68 will give you minus 1, right? Here you can see, and 67 by 68 will give you minus 1. So this both will be added up to give you minus 2, right? When this entire statement, okay, the question as given, you can see minus 2 is left. That means when 68, from 68 you are dividing it, right, it will not be divisible, right? So it will be divisible only when 66 will be added, because this minus 2 is left over remainder. Minus 2 is left. So that means 66 need to be added, then only it will be completely divided by 68. So we can say whatever is added, that will be left over into the denominator, and that's our remainder, right? Thank you so much for watching, students. For any query you can put up into the comment box. Thank you. Take care. Bye bye.